Okay, come, children. Last week, right, we are doing something called prime factorization. All right. Then last week we did something called HCF and LCM. All right, Hashnan, last week you never come. Look at these beautiful notes. Can you see or not? Can you see so beautiful? Yeah, don't worry about this. All right, you are able to download this. All right, after you download it, right, you can actually cut it out and paste into your exercise book. So usually I require the students to have an exercise book lah. All right. So last week we talked about something called prime factorization. I even gave you guys my personal number. All right, this is the math hotline. Right, because you are my student. All right. So in future, if you have any school related homework, right, if you don't know how to do, you can actually drop me a message. Can? Right, but don't give me the entire homework, lah, right? There must be like 1 or 2 questions that you don't know. So those questions that you don't know, I'm able to help you. So take a clear picture of the question and send it to this number, 89330213. All right, that is because you guys are my student. You are my responsibility. I want to help you as best as I can. Can? All right, so last week we also talked about something called HCF, LCM. There are 3 methods, the primary 4 method and the 2 sec 1 method. All right, there's this L-shaped method. All right, instead of calling it the L method or the loser method, we call it the lavish method. All right, make it a little bit more high class. All right, and we also talk about something called high take low, low take high. All right, so these are things that we went through last week. All right, just to give Ashnan a idea of what is happening last week. Okay, so last week, right, I didn't manage to attempt a couple of the homework. All right, that's why I gave out this question as a homework. All right, this was last week question number 4. This was last week's homework, worksheet 1, question number 4. All right, so we did halfway. We did halfway. All right, and I think that it's important to show all of you. All right, so there are 2 parts to the question. First, they asked me to find the HCF and the LCM of these 3 number, 63, 105, and 420, which I did it using the lavish method. All right. So the lavish method, you have to go and find the HCF first. Then you can then find the LCM. How do you find the HCF? You must divide these 3 number by the common prime number. So all 3 of these are what? They are multiples of 3. So I divide them by 3 for all of them. After that, the second line down here, I can see that they are all multiples of 7. All right, so I divide them by 7. And after that, I get something called 3, 5, and 20. There's nothing else in common. So this portion will give me the HCF, all right, which is 3 times 7, which is a 21. Then the question asked me to find LCM. So I got no choice but to go further. So I have to restart the prime number with a 2 again. All right. So at this moment, there's a 20. So 20 is an even number. So the only way to break the number 20 is with a even prime number, which is a 2. So you divide by 2, you get a 10. The rest cannot divide by 2. You just copy downwards. Just copy downwards. After dividing by 2, I still can divide by another 2. All right, 10 divided by 2 to give me a 5. All right, then after that, what happened? Oh, I divide by 3. Down here, 3 divided by 3 to give me a 1. All right, and lastly, I divide by 5 to give me a 1, 1. So LCM, right, you have to reach the objective of 1, 1. Right, that's the objective for LCM. And the whole thing here will consist of your LCM. You write it as an index notation or product of prime factor 2 to the power of 2 times 3 to the power of 2 times 5 times 7. So this is what we did last week. All right, just want to give you a recap about this lavish method. Okay, then the second portion, I gave it as a homework. I say the homework is for the 10th of Jan. How do I continue? Can you see now? Can you see the keyword here? It's called hence. What's the meaning of hence? Hence means you have to relate back to part A. So in future, right, when you see the word hence, you have to relate back to the previous part. All right, you have to relate back to the previous part to assist you. All right, can you see something? Hey, why the HCF is 3 times 7? Heidi, down here, is it? What do you mean? The HCF is 3 times 7, what? That time we did that already. What do you mean by why the HCF is 3 times 7? Right, because I'm using this L method, remember not? Right, okay. Heidi, for example, I have two numbers. Let's say 24 and maybe 35. All right, or maybe 24 and 36. All right, Heidi? All right, so I'm looking for something called the HCF. How to find the HCF? I use this L-shaped method, the lavish method. All right, so as you can see, 24 and 36, they are part of the even numbers. So I can divide by 2. So both of them can divide by 2. I go ahead to divide by 2. All right, 12 and 18, they are even numbers. So I divide by 2 again. 6 and 9 no longer even, cannot divide by 2. So I divide by the next prime number, which is a 3. All right, and I stop here. I cannot go further. There isn't any number which can be divisible by 2 and 3. All right, there isn't a common number that can be divisible by 2 and 3. So in this case, this whole thing will be the what? Heidi? This whole thing will be the HCF. Can you see that? So HCF is 2 squared times 3, which is equal to 12 lah. Right, it's the same method I use for the on top part. Are you okay or not? Because you're asking me why the HCF is 3 times 7. Because through my working, it is lah. Through my working, it is. Right, so this is another example for you. Right, I don't know if you can see or not, because you're on the bus now, right? Yeah, I hope that you can see. Can? And for this lavish method, right, in order to find the LCM, I need to go down all the way to a 1, 1. So I divide by 2 again to reach a 1. But 3 cannot divide by 2, it's a 3. I leave it. All right, now I need to divide by a 3 to get a 1, 1. Woohoo! This is my objective. So what is my LCM? My LCM is the whole entire thing. All right, not just the blue color. So LCM is actually 2 to the power of 3 times 3 squared. All right, which is equal to 2 times 2 times 2 is 8. 8 times 9 is 72. All right, if the question asks you to work it out. Is this okay, children? Right, Husnan, okay? Are you doing this in school also? Yes, right. Yes, okay, very good. All right, so there's just an extra example. All right, so this is the slightly harder part, part B. Why? Because there are what? There are another portion to it. There's the alphabet portion. Can you see not? This is the alphabet. Terrible. Sure. All right, so children, this is like the hardest it can go for HCF and LCM using the lavish method. This is the hardest it can go, right? If you're using the HCF, LCM for the lavish method. So what do you see? As you can see the word hence, right, means you have to relate to part A. And part A, they are talking about these 3 numbers, 63, 105, and 420. Can you see that these 3 numbers appear here also? 63, 105, and 420. Can you see? Right. So let's follow the color coding. The purple is the number. The purple is the number 63, 105, and 420, which has already been done in part A. Which has already been done in part A. Is that okay? All right. So in part A, right, the HCF is equal to what? Is equal to 3 times 7, 21. Is that okay? Right. In part A, the LCM is what? The LCM, let me press my calculator. Is 2 to the power of 2. Learn to press your calculator. Times 3 to the power of 2 times 5 times 7, which is a 1260. 1260. Okay? This is what is found in part A. So part A, the HCF is 21. The LCM is 1260 for these 3 numbers. Are you clear? All right. So for part B, all right, so for part B, right, what happened? They are looking for the HCF again. Can you see? All right, let's follow the correct color. Let's follow the correct color. HCF is what? For the numbers, it is 21. For the number side, it is 21. Okay? For the LCM, right, the number is 1260. All right, the number is 1260 on top there. It's done. Okay? But now we are supposed to do the what? We are supposed to do the alphabet. right? We are supposed to do the alphabet part, which is the tough portion, right? Which is the difficult portion. Are you ready? Okay, come. So what do? You do as per normal, children. You do as per normal. All right. You are supposed to what? You are supposed to do the HCF first, followed by the LCM. We are doing the alphabet. Alphabet is your A squared BC. Can you see the tick? Alphabet is your AC cube and also your A5 B cube C square. Are you ready? Okay, let's go. So same down here. Let's use the lavish method. Let's use the L method. All right. Okay. So looking at these three, what is common? Sure, there's no more prime numbers. Yes, I know. But it still can work. So what is common between these three? Can you see that the alphabet A is common? Can you see that the alphabet A is common? A squared BC, AC cube, A5B cube C squared. The alphabet A is common, so you divide by A. It works. It works the same. It's the same idea. Right, so if you divide by A, right, what are you left with? You're left with A, B, C. All right, the second one, AC cube divided by A, you're left with C cube. Are you still following me? A5B cube C squared, if you divide by A, you're left with A4 B cube C squared. Okay? Okay? That is for A only. Then now you look at down here. You look down here. Look at the second line. What is common? This one got A, this one got A, but down here got no more A. Can you divide by A? Cannot. Remember HCF, you have to divide by the common thing. You cannot divide by A already. Can I divide by B? Down here got B, down here got B, but down here got no B. Cannot divide by B. What can you divide? Divide by C. All right, you can divide by C because all three of them got C. So ABC divided by C is a AB. C cube divided by C is a C square. A4B cube C squared divided by C is a A4 B cube C. All right, and you stop down here. Why do you stop down here? Are there anything else in common? Nothing else in common already. Can you see now? AB, C squared, A4, B cube C. There's nothing else in common already. So these two, right? These two will be your what? These two, oops, sorry. These two will be your HCF. Do you know? It can be done. It's the same method. It's the same method as this. It's the same method as this. But down here, we are using something called the prime numbers, 2, 3, 5, 7, 11. Down here, there isn't any number. You can use the same alphabet. So this is the hardest it can go. All right, this is the hardest question it can go if they bring in the alphabet. All right, this is for the higher order kids. Right, if you can understand, good for you. Right, because if it comes out right, you are at the benefit here. Can? So in this case, your HCF is AC. So down here, you are supposed to put your AC back here. Right? How do I get the 21? The 21 is from the previous part, which is 21 down here. Right? So that part is done already. Just follow the color coding. Purple is done. All right, now we are doing the box, the red color box. Okay, how do you find the LCM? Because LCM, I still need to do this part. Right? You see the LCM? I still need to fill in this portion, LCM. So how? All right, LCM, my objective is to reach a what? Remember my objective? Is to reach a 1, 1, 1. Remember or not? Okay, come. So I purposely go up and divide by A again. All right, those can divide. Those cannot, never mind. So AB divided by A, you're left with B. C squared, nothing to divide, leave it as C squared. A4B cube C divided by A is a A cube B cube C. Continue to divide by A until there's no more A. Right, so it works the same as for the prime numbers. Can you see it? It works the same. So I divide by another A because down here got a lot of A. All right, down here left with one A already. All right, divide by another A so that I'm left with B C squared. B cube C. No more A. Are you happy? Are you happy? No more A. Happy? Okay. Next. Divide by what? Next alphabet is a B. All right. If I divide by B, this right, becomes a 1 already. Very good. C squared is still a C squared remain. B cube becomes a B squared. Okay? Can still divide by B again. 1 C squared B C. Divide by B again. Can you see or not? right? Because you need to move on.